everyone. Welcome to our webinar today. We're just about ready to get started. So with that being said, I'm going to introduce our moderator today, Mike Watson. He's the VP of Engineering at CenterZip Prime. And I'm just turning it over to you, Mike.
Thanks, Phil. Welcome everyone to today's webinar, which is about Kubernetes and serverless. We have a great speaker today, interesting topic. I'm going to give you a little bit of background on what I think about the topic. So, this serverless and Kubernetes thing seems to be the latest battleground in software deployment architecture. And a lot of us it's unclear what should we be doing? Like, what's the right answer? Like, is serverless better? Is it worse? Like, what situations should we use them in? So hopefully by the end of this webinar, we'll have answered a little bit of that question. But like with all technology considerations, it really depends on your situation. So there's no right answer. There's answers that are righter than others for your situation. So just keep that in mind, and hopefully we'll help you see what those factors are. So with that, I'm going to introduce you to Matt Ward. He's a software developer with Mux, and I'm excited to hear his perspective on this topic and get to chat with him about it.
Yeah, thanks for having me, Mike. Great to be here, and hopefully we can have a little bit of a discussion or an argument to some extent on which one's better, but we'll see how that all goes. Yeah, should I get some slides started for everyone? We can tell you a little bit more about me. Yeah, I'm going to talk a little bit today about the kind of Kubernetes versus serverless landscape and how I'm thinking about it and how we made our decision at Mux. So before we get too far into that, I'll tell you a little bit about myself and about Mux. I've kind of had a background through mostly actually doing video technology. Even some of my freelance gigs were building video websites for people. Specifically worked with a guy who was doing online physical therapy and would record physical therapy classes and instruction and have, this little hosted video thing. And so I, in my freelancing career, was writing Flash. And when I applied to the not freelancing world of jobs, I ended up with a job at YouTube because of my kind of Flash experience. And after that, I joined Mux, and I've been kind of leading the SRE and platform team there. And most recently, I've kind of switched more into research and development for some new products and features that we're working on. So it's a little bit about me. And then Mux, if you haven't heard of us, we are basically trying to do video for developers. Our goal is really to solve these hard problems in video that we think just everybody faces when you're doing video at some scale. And that fundamentally breaks down into two categories. The first is Mux data, which is just monitoring of video playback. Specifically, we have been focused on quality of experience. And that really means, okay, is the video buffering? Is the video starting quickly? What is the actual end user experience like? And we're doing that with a number of companies and names that you may have heard of. We've been working with them for a good bit. That was our first product that we put out into the market. And then a few years ago, we got into video publishing, and we are doing kind of an at-scale video publishing service where you hand us the video and the asset, and we kind of take care of the rest. You can bring your own player, which a lot of our customers like to kind of have that customization that really makes it feel like their player and their product. We're really the under the hood infrastructure for that video application, helping handle all the CDN integrations, all the transcoding, ingest, everything is kind of handled by us. So if we go back to a long time ago, at the beginning of our startup journey, our little 5-person-ish engineering team at this early stage startup made the decision to go into Kubernetes as our main platform for orchestration. And we did this at the time for a number of reasons. And I think some of the things weren't completely clear at the time, but we have definitely seen a number of benefits from making this decision that I'll try and get into the details of a little bit right now. So the kind of first thing to mention is visibility and how important that is to us. It's important to note that we don't actually use hosted Kubernetes solutions. So we don't use, your GKE, EKS, or any of those solutions. We actually roll our own Kubernetes master nodes, which kind of control the whole cluster. They're running the API servers and everything. And that gives us some really good insights into, okay, how are we interacting with these API servers? How are they doing in terms of load and performance? And do we need to scale them out? We have heard stories and have brought people on board on our team that have had problems because they were lacking visibility into the control plane and just were not sure, okay, how far out is this going to scale? Can it handle, all the load that I'm throwing at it? And especially this kind of becomes true when you're like adding more and more applications to the cluster. You'll kind of go shopping for like Kubernetes operators and drop them in, and they'll like have this great promise of making X, Y, and Z application operations easier. And they end up doing a ton of API server calls and interactions, and you're kind of wondering, okay, what's the impact of that? Is everything still okay? Or maybe what's about to happen. You need to kind of pre-scale. So it kind of gives you just this layer of insight into how things are working that has been beneficial for us. And then that goes all the way down to the networking stack too, because we're able to roll our own networking infrastructure. Specifically in Kubernetes, this is called the container networking interface. So it's how the containers actually all talk to each other. We're able to pick the solution there and decide what works best for us. So making the right selection there, you can end up with things like basically the application doesn't need to worry about encryption. Everything can just talk to each other encrypted because your networking interface handles all of that for you. And in some of the stuff that we're switching to, you can get really, really detailed monitoring of network packets down to the point of, okay, how many reset packets were sent around my cluster? Was there a massive spike in that? And for us, some of this detailed monitoring has helped us in debugging the large amount of network traffic that we're doing, as well as kind of this. There's some complicated use cases we have around really long-lived connections, and rolling our own infrastructure and really getting down into the network has let us solve some problems that would be significantly more challenging if we couldn't get all the way down to the deepest parts of the system. And the last part on the visibility side that I want to mention is, in order to be competitive with, there's so many other products in the market, we really needed to have detailed tagging and reporting of our spend in our infrastructure. And that was something that we were able to do early on with Kubernetes because of the various APIs and interactions that we could do. So that's kind of the gist of why visibility, or I guess what we get on the visibility side. The next part is consistency and customization. It's as much about the developer experience here as it is about the actual production infrastructure being consistent. At the end of the day, we're running across multiple clouds. Our developers sometimes are jumping across different clusters to debug multi-region problems, and across each of those clusters, there's this unified tracing, logging, and metrics infrastructure that we've deployed on top of Kubernetes. And it's really easy for us to bootstrap because we have the same API across cloud providers and whatnot. We basically look at our cloud providers as compute, storage, and like networking. It's a very kind of simple way to think about that interaction. And for us, that's really led to, this ease of, okay, everything that you look at from an application developer perspective is consistent, and how to deal with it, whether it's on AWS, GCP, Azure, whatever you have running. The next part with that's kind of neat is it extends into our development or deployment APIs rather. And for us, it's, really nice to not have to rebuild our whole CI and CD stack when we're switching or adding another cloud provider. That's been kind of a big win. Or, I mean, looping back to the beginning here, when a dev is switching teams, they're not worried about, oh, well, does that team do something different than the team I was just on at our company? No, with everyone using the same API, it's kind of means this consistency and team portability is nice. And the last point here on kind of the same team supporting it, we have one infrastructure kind of platform and SRE group that ends up supporting all of the infrastructure that I just mentioned. And for us, there's just kind of one group. We have one platform that we're supporting. It's not a ton of different things. And fundamentally, we're there to help support some of the lower level Kubernetes problems that end up popping up. So.
Hey, Matt, quick question on that last point or that last part. So did you stumble across using Kubernetes bare inside the environment, or is that an explicit decision from the beginning? You knew that was the right thing to do?
Yeah, I think at this point, it's become the right thing to do in our mind. Early on, there wasn't another option. Like when we adopted Kubernetes, it was like, you roll this yourself or you don't use it. And so we've been doing it for so long that at the time that we adopted it, there really wasn't a choice, right? And so in a way, we stumbled into it. But at the end of the day, we've ended up really benefiting from that experience of having to bootstrap and run that server completely on our own.
Awesome.
Does that make sense, Mike?
Yeah, it totally makes sense. Oh, and by the way, if any of you out there in the audience have questions, please feel free to type them in the chat box. We'd love to hear from Matt.
I'm a little disappointed. I want some more heckling or some hard questions. Bring them on. Bring them in. Let's go. Okay. So I just talked a little bit about team that supports it. I should talk a little bit more about our application and performance. I talked about the debugging side as well. And sometimes when we're digging in to debug specifically some of our performance problems, we end up having to make some decisions that I think you can't do without getting closer to the infrastructure. And for us, this ends up being like, okay, what's the biggest machine that we can run so that we can run across as many cores as possible? How do we pull in the highest performance disks? Because we're doing tons of I/O for video transcoding. And even for kind of our data stream processing workloads, we're using Kafka extensively at Mux, and having large high performance disks when we have to go process large batches of data has helped us kind of scale that out more easily. So on the performance side, I think like this is a kind of toss up between a lot of the options out there, unless you're doing things that really use multiple cores and are highly concurrent, have a lot of I/O. You can probably get reasonable performance out of a lot of solutions. People are always working really hard, but at the end of the day, we have full control over the thing, and we can kind of balance our spend as well as kind of our performance decisions, which starts to lead me a little bit into the next point, which is the scale of Kubernetes deployments is just so different from everything else out there that you might be looking at where there's hosted solutions. The limits are basically what you can get in terms of compute and storage and all of that. And usually those go significantly higher than a lot of the other options out there. The one that I always joke about is concurrency limits on applications. I think, some people running in the serverless world may have heard of concurrency limits before and hit them. We've done some large events that we knew that a massive load spike was coming. And I've heard of people running applications serverless where they're like, warming up and running all these things to try and make sure that, the application's scaled out for them, because there's not just a button they can press. And in our world, there's just really kubectl scale, and you're going. And that lets us pre-scale for big events and not be worried about, okay, is the serverless platform going to do that for me? So like I mentioned coming into this slide, the last bit is customizing scaling parameters. Kubernetes is like really extensible. So for us, we have dug into the Kubernetes API and written some custom scalers for our application that take into account, okay, how many cores of overhead do we want? And that lets us balance. Yeah, the scaling performance is, I think, it's not so much about how quickly you scale up and down, but as much about what are the machines and like workloads that you're scaling. For us, we take advantage of preemptible instances as well, or spot instances, and work that in, and then we kind of have custom logic that lets us decide what runs on which machines. And that helps us both balance kind of performance and cost, and really lets us get in there to figure out, what's the best way to run this application. Some of this is made really easy because of the ecosystem around all of the software. For us getting started, I think we were really worried about investing in Kubernetes because we had such a small team. I think by far, this is our number one concern. We've learned in the time that we've been operating it that the community here is gigantic. They're writing resources to help you learn Kubernetes these days that are just absolutely excellent. I mean, just the Kubernetes website, there's multiple classes that people can take to learn the ins and outs. There's certifications, everything has really, really blossomed here. So once you've kind of learned how to run all this stuff, learned a little bit about the APIs, learned how, the whole entire application and platform interact, you can start to understand the world of operators, which is, I think, the kind of next step in really just running software at scale. It's moving our hand operations that we've been doing for years as operations professionals into code, and making it so that rather than executing run books by hand, copy pasting things into terminals and saying, okay, I'm running this now, here goes that. Instead, we have piles of code that do this for us that are tested across probably multiple companies running the same code and same logic for, say, doing Postgres backups or scaling out your Elasticsearch cluster. All of that can be done now as code using operators, which are interacting with the Kubernetes API, checking in with the actual applications running on Kubernetes, and handling a lot of this manual stuff that we did in the past automatically. And I think that's really going to reduce the burden of our operations teams in the future as more and more people invest in building these.
Yeah, on this topic, I don't know how much, how deep you are in the serverless world, but what do you think about the ecosystem there? Do you think it's just a few years behind, or do you think it's also evolving in such a way that later it'll be a strength?
That's a good question. I think, I've heard of some efforts to like standardize around like how you're actually writing the function implementations that are running in your serverless platforms, so that they're more portable. I think that's bringing a lot of that world up to speed with what we have with the Kubernetes API, where there's at least some unification. I think the biggest thing that will remain is just every single platform that you're considering to run your serverless, workloads has some set of dependent resources to actually learn that. And, those are pretty stuck into that platform and that application, or that, provider, where when you're learning Kubernetes, it's kind of become more portable. which I don't see the serverless world quite getting there without standardizing that API that I was talking about. As far as I know, Mike, you can correct me if I'm wrong, but isn't like the function signature and like how you actually even implement functions or define, interfaces into your serverless calls, that's not standardized yet, right?
Yeah, not that I know of. There's probably some efforts to standardize that, but I'm sure it's more of a third-party effort than it is, a cloud-specific effort. Although
Yeah.
I heard something interesting. I was listening to serverless chats yesterday. I ran out of episodes of Conan Needs a Friend and decided to listen to something relevant to business, and it was about Azure Functions. And apparently, the Azure Functions framework is open source, and it can run on any compute. So I thought that was
Oh,
quite.
neat. Yeah, I actually think that's a good transition into this next slide. Running on any compute, I think, is um, a little bit of the challenge of Kubernetes is like one of the compute environments where you need to run is like your dev environment. And that's, I think, one of the things early on we struggled with the most was, okay, how do we get the same thing, same environment that we're running in our staging and production uh, environments on your dev machine? Because consistency in that workflow from start to finish, I think, has always been an important thing where you're not having a totally different experience on your dev box versus what's going to happen when you get to production. I mean, if that's the case, you're going to have even more problems and things to debug. And this really has kind of started to get better. The folks over at Rancher have created K3S, and K3S is they say it's 5 less Kubernetes, 5 times lighter, right? And we're running that locally. It's got the full Kubernetes API, but it's so much lighter weight that it runs much more easily on our laptops when we're trying to just quickly iterate on some code locally. At the end of the day, the big iteration and testing sometimes does happen in our staging environments because we're trying to load test performance issues, and so some things will not really always run on your laptop. I think this is true for a lot of applications out there, but having a way to run it on your laptop and kind of you know just be quick in iterating without having to push continuously to the cloud and all of that stuff, I think is really important. And it's something we definitely struggled with early on, and a lot of developers, I think, struggle with. In fact, one of the companies that's just spun up around this too is called Tilt. And Tilt is also trying to fix this problem because there's also like the dependency issue of like, okay, how do you spin up microservice or Kubernetes workload A before B, right? Because maybe it needs to place a call to it or something in order to bootstrap, and you've got all these scripts to actually load your databases, which is kind of databases and data storage are still there, right? Those problems don't go away with Kubernetes or with serverless. I think at the end of the day, a lot of the stuff that is hard problems is still okay. Where are we storing the data? How are we interacting with it? How quickly can we access it? And how you architect and how you think about your whole application um, in both the serverless and Kubernetes world. I think a lot of it boils down to where's the data, how am I storing it, and those are some of the hardest decisions you'll make. And that space kind of looks similar. We have run on RDS with our Kubernetes deployments because I mean they take so much of the operations off of our team, and the Postgres Kubernetes operators that we had tried a while ago were not quite there yet in terms of backup ability and failover when a node fails. So I guess, yeah, this is kind of, trying to start to get a little bit more into the trade-offs between Kubernetes and serverless, which I think Mike and I will talk about a little bit more in a second. But the last thing to say is like debugging and bugs. Application bugs are always going to be there. With Kubernetes, when you're debugging a bug and you start to get into the internals of Kubernetes, if you haven't spent some time in there, if you're not comfortable digging into some of their code or Googling around the internet sometimes, right? You might be in for a world of pain. But the good side is, there is a large ecosystem and community there to support you. There's a great Kubernetes Slack group to join if you want to dig in. People are always there helping you. And if you're working with a cloud provider, frequently your support teams from the cloud provider will be able to help you with some of your Kubernetes problems and workloads that are experiencing issues or whatever. So lots of options for support, but.
So Matt, we got a question from the audience. Probably a good time to ask it. They're saying that they work with GCP and they really struggle to find and debug issues. Do you have any hints on how to, inside of your containers, get a little better insight to what's going on?
Oh, well, I think, this kind of goes back to one of the things early on around why we run it ourselves. To some extent with, I assume by GCP here, we're talking about GKE, right? To some extent, there's only so much that you can dig into because the cloud providers have a certain abstraction layer. And if you can't get into, the actual logs of the API servers, maybe you can get into, I think with GKE, you have like actual compute nodes that spin up and you can log onto those. And if that's the case, maybe some of the kubelet logs would be helpful in debugging that. Also, just, yeah, the support team and support tickets are kind of where I would lean on there. I'm sure that you're not the only one out there feeling that pain. I know we use GCP a good bit and kind of our interactions with the storage system. There were some networking issues yesterday. There's been bugs on their end. There's always bugs, right? And there's always issues, and debugging them is hard. I don't have a silver bullet. If I did, I think I'd be pretty successful on it.
Yeah. So is it possible to get thread dumps? I mean, it's kind of a similar question, but is it possible to get thread dumps when you're in that kind of environment, or is that only when you're running it yourself?
Yeah, I mean, so our application is mostly Go routines, Go. And so Go routine dumps and kind of the Go profiling tools are exposed for us because we configure our Kubernetes applications to expose that. We kind of have an internal, port that basically has our metrics, our profiling, and all of that available. That's firewalled off, and that lets us just quickly curl an endpoint and see every running Go routine in our applications. So we do have that today. I'm not sure that there's a specific there that's like Go specific, but yeah.
Yeah. So when you access that, are you so it sounds like you're using like a bastion kind of concept to tunnel in there.
Well, so that's one of the neat things with Kubernetes is so the abstraction called a pod, that's basically a single running instance of your workload. You can basically port forward from that pod to your local machine, and it makes debugging really easy because if you have basically that internal port with your metrics and with your profiling tools and all of that, you can just hit that on your local machine and port forward to it. And, we rely extensively on that for our debugging workflow. So there's kind of a built-in thing in the application, in the Kubernetes platform there to help make that access really easy.
I see. They just responded to that, answered the question, so that's good.
Cool. Well, so I think one of the things I wanted to talk about, we're kind of getting into a little bit here, is when should you do serverless and when should you do Kubernetes? I think we're in an interesting spot where we're doing video transcode workloads. And early on, a lot of companies are not struggling with large compute requirements and are struggling more with product market fit. And the quickest way to iterate on your application might not be Kubernetes. And so you kind of have to think, okay, how much do I care about my control of my infrastructure and how I'm running this versus how much do I care about how quick I can iterate on it? And sometimes, serverless platforms can be quicker and easier to iterate on. The last bit here that I think is interesting to note is they're not necessarily mutually exclusive. There are platforms like Kubeless, Knative, I think is the other one, that are enabling basically serverless-like workflows on Kubernetes. And that can give you some of the benefits that we talked about earlier around, okay, can I pre-scale this out, et cetera, while still giving you those workflows that devs are starting to love, that you're getting with serverless. So you get some of that ecosystem, some of the Kubernetes ecosystem, and that's an interesting space right now, I think.
Yeah, so that's kind of in line with what we were talking about with the Azure functions, being able to, you deploy Azure Function Framework onto your Kubernetes cluster if that's what you wanted to do. So that leads me to a point of, one of the things that they tout in the serverless world is, rapidly throwing out a function, right? So you just write some code and you put it up into the console window, and boom, you've got code available to run. How close can you get to that in the Kubernetes world?
That's a good question. I think the first thing to think about here is the fundamental thing you're running in Kubernetes is a container. And how quickly can you get from my application compiles and builds a container to it running on Kubernetes starts to vary a little bit around your tooling. And I think the tooling there is getting better and better. But today, it's still this extra step of writing manifests and, okay, did I push the image out there? And there's this whole workflow with a bunch of steps in it, which, yeah, there's probably more steps there for Kubernetes. It's probably much slower. I think that's, again, why devs are thinking more and more, oh, well, I'll just use serverless because it's quick and easy, and I just type these 4 commands and this thing all works. There's not really 4 commands to get out on Kubernetes, right? The tooling is getting better, the community's evolving, but it's not quite as fast yet,
Yeah, understood. Back when I was investigating it, say 5 years ago, I mean, at that time, Docker Cloud was, or not Docker Cloud, Docker Swarm was still a thing.
Oh yeah.
Quickly blew past that because it's irrelevant, but it was
we were running on Compose, so Docker Compose is another great one. I think a lot of people that were starting to jump on Docker were using Compose, and I kind of look at that and Kubernetes as kind of similar, right? It's like once you have the actual container running, it's how do you connect them, get them together to work, as one big application rather than a bunch of individual little pieces. And at the end of the day, it ends up looking pretty similar, and the APIs and whatnot are the big difference between like a Docker Compose or a Kubernetes, or people were messing with like Mesos and a bunch of other orchestration platforms out there, and it's really the API that Kubernetes provides that makes it so powerful at the end of the day, and kind of the ecosystem of tools and things that people have built on top of that.
Yeah, that makes sense. So I imagine setting up a Kubernetes cluster is much easier than it was then, and it probably runs way better than it did then. Because I remember I put it on my, business style laptop that had extra memory, so I pretended I was a developer, and it just, it basically crippled it. Just having, the base Kubernetes plane and infrastructure in there. I'm sure that's not the case anymore, but those were the.
Well, it might be. I think it depends. There's a few things there, right? Like the first is the actual Kubernetes control plane API, right? Its own database is the first workload that you're running. And Kubernetes compiled in the way that you would like run it in production and how we do from like the main Kubernetes repo, it's a pretty heavy application and it takes some resources to run. That's part of why I mentioned K3S earlier, is it's just, they've kind of stripped down a lot of the dependencies there in order to just make them run locally with like some compromises that maybe it's not the most HA system on earth. But the idea is really just to reduce the size of that. That doesn't really matter if your application's still gigantic and you're trying to like run a giant workload. It doesn't matter if it's serverless or if it's Kubernetes or Docker. If your application is still gigantic and you're trying to run it on a under provisioned machine and you're like overutilizing it, you're just going to have a bad time no matter what. It doesn't matter what you're using.
Yeah, gotcha. So there's a bunch of questions coming in from the audience. Great. Thank you for that.
Yeah, perfect. Well,
I'm just going to run through some of those. They'll probably be all over the place. So
that's this. Let's switch to just chatting through some questions then. And thanks everyone for listening to me blabber on there for a minute. So much that I, struggled to speak a little bit.
Yeah, so most of these questions are around, more detailed questions around, if I'm setting Kubernetes, what are your recommendations for this, that, the other thing? One question was, have you kept your databases and your caches running outside of Kubernetes? Or do you sometimes find use cases where you can run them, should run them inside the container?
Well, inside the Kubernetes cluster, I would assume is kind of what we're talking about here, right? And
that's correct.
I think for that, it's mostly inside of the Kubernetes cluster now. Like I said earlier, on some of our critical application databases, we were running on RDS before kind of the ecosystem started to harden up around the Postgres operator specifically. There was not really a great story around running Postgres in Kubernetes. How do I handle like a random node failed? What do I do now? Are there backups? There's starting to be operators that can handle that. And I would lean on that more and try some of them out if I was starting again. We just have some stuff still running in like RDS from older decisions that we made before some of that stuff existed. So we do use that and do use some hosted solutions there. Our biggest database is, we actually partner with CockroachDB, and that actually runs inside of our Kubernetes cluster. It's designed for random node failures, and it actually exposes the same API as Postgres. So our newer applications that we've been writing are mostly using that for kind of application state storage. And it's been great. It's highly fault tolerant. We have no problems rolling nodes. And then some of the other database style workloads that we run a good bit of Redis, which runs inside of our Kubernetes cluster. And with Redis Sentinel and some of kind of the tools around that, we've had no problems again dealing with failures there. The biggest thing with all of this is like, how much does it fail and how guaranteed are you that like, okay, a random node dying or that database dying, your application keeps surviving. And no matter what, there's still those challenges on the application layer, whether you're using a hosted solution or you're using kind of a database running in your own cluster. So some of that stuff doesn't go away no matter what choice you make. You just maybe get a little bit more visibility if you're running it inside of Kubernetes.
Yeah, makes sense. So you talked about Cockroach. So what do you think the pros and cons of running something like Cockroach is?
Yeah. So the first thing to say about Cockroach is they're open core. So they're like fundamental database you can run for free. When you hit a certain scale, it's different. It's not Postgres. It's got its own intricacies, and when you're really trying to scale that out, we've been lucky enough to work with the Cockroach team there and understand, okay, how are we designing the key space so that it scales out correctly, because some of that stuff's not immediately intuitive. It's not Postgres, and a lot of us have been operating Postgres for a really long time, and so its main cons are that the new technology problem exists, and you've got to learn a new thing, and you've got to possibly lean on an enterprise support channel if you're trying to do it quickly, and so on the opposite side, right, the biggest pro is you can lean on an enterprise support channel. So yeah.
Yeah, that is nice. Let me look through these questions a little more. So
Sure.
So when you're scaling, how do you decide to go, wide or fat, so to speak? Big, wide or tall, I guess is a better way.
Yeah, that's a good one. I think a fun one that I'll use here is our transcoding workloads. Like you might be tempted, right, to just say, oh, well, make as much of that run on the same machine as possible if there's enough CPU for it. But then you forget about disks, and like at the end of the day, maybe your disk IO ends up being the problem. And so it ends up being a question, like most application scaling questions, of which resource is being utilized the most, and can it actually fully utilize all of the cores that you're throwing at it if you're going fat, or I guess that's tall, right? Because it's like one machine is tall, and then there's multiple of them if you're going wide parallel.
I think it's more PC to say tall.
Yeah, right. If you can ensure your application can do both, you're kind of in the best situation. If your application can never go like horizontally scale, you're going to be in the worst situation because you're going to be capped by the maximum size machine that you can buy. And you only want to be in, I think, the position where you're buying the maximum size machine that you can buy when you're doing kind of like a cost optimization and you're like, okay, well, we're going to really bin pack that. You don't want to be there because you're like, okay, this application is not going to work if we don't buy the most expensive, biggest machine on the market. That's going to really hamper you. And so always trying to be kind of scaling horizontally just makes your workload a little bit more flexible, I think.
Yeah, gotcha. Yeah, that is. I think there's two interesting points there that you mentioned that I'm just going to touch on. One is that your compute may not be your bottleneck, and I think
Totally.
earlier, offline, you said frequently that is the case, like very frequently. So
Yeah.
the question might be moot a lot of times because you have to look at some other aspect. And the other thing was there is a limit to how big you can go, like how tall is, which
Yeah.
is less true if you're doing your own hosting, right? In theory. So that's
In theory, but like, I haven't seen anyone buying 1,000 core machines, like single machines. So
yeah. Fair enough. But there is some kind of crazy, some high-end limit. So you probably want to make sure you architect where you don't just have to go tall. Like I've worked on a system with a big data system where we just had to keep adding memory and CPUs to it to our database so that it could keep processing. Right, we just had to keep going tall because we didn't have it architected in a way that made it possible to go wide. So
oh no.
those were the bits.
Yeah. I mean, some of that, Mike, goes back to earlier, right? It's like a lot of this ends up being like you have to make application changes in either situation to scale, right? In that case, I would assume that you probably end up with a solution where you're doing something like partitioning the database, and the application needs to become aware of like partition handling. And
yeah, exactly.
There's code to write.
Yeah. I mean, it was certainly there were some architectural decisions early on in that company's history that locked us into certain decisions. How much can you spend refactoring to solve these things versus let's just add some more disk or not really disk but memory, and usually memory was a big thing in our case.
That's a great point. I think the big advice I always tell friends on early stage startups that are trying to scale is just like can you just buy more compute and go like vertically without like having to think very hard? And how long can you get that to last? And ideally, you can hit product market fit and like build a successful company without having to put too many engineering hours into rebuilding or rewriting large parts of your code to scale horizontally. So sometimes you have to do that, right? Like in the case we just talked about, databases don't partition themselves.
Yeah, that is true. And you usually or probably always have to write code to deal with it.
Yep.
So this is sort of off topic, but I think it's interesting. I had the same question in my mind. So are you using Kafka in the same way, Kafka, or are you using, what's provided by the cloud providers?
Oh, we run all of our own Kafka, and that was actually one of the first workloads and reasons that we switched into Kubernetes is because we were having problems scaling out Kinesis, and we were hitting upper limits on how far we could scale Kinesis because of the size of the workloads that we were handling. And that was the first case. If we got to write a bunch of code and we got to switch off of this because it's not going to go, to the scale that we need to run at. And it let us basically get a little bit more insight into where those limits were. One of the problems we had, going back to the visibility and like observability problem with using a cloud provided solution there, was it wasn't clear until the application started erroring how close we were to hitting the limits. We just were like, okay, there is an upper line, and like on some of the graphs in CloudWatch you would see a red line, and on some of them you wouldn't, and you would just be like, is that one the problem? Is that one the problem? And so it kind of became a guessing game, which is the worst case to be in, or the worst situation to be in when you're trying to scale out the application and ensure that you can keep your customers happy.
Yeah, I guess that's a classic scaling problem, right? It doesn't slowly break. It all of a sudden just catastrophically breaks.
Usually at 3:30 in the morning, if I'm remembering correctly.
Yeah. It waits for the optimum time to wake
Yep.
up. Let's see, what else do we got here? So, how do you deal with like connecting to the cloud infrastructure, like the networking of the cloud infrastructure, and what does your pipeline look like there, and do you use SSL, and is that fast enough? Talk about that.
Yeah. Okay, I'm going to talk about this in the easy in a single cluster situation, and then make sure I hit the cross cloud situation at the end here. Hold me accountable, Mike. So at the base level, for us, in our latest and greatest clusters, we're running Cilium, and Cilium has a number of features in it that basically it's doing networking via BPF, and you can have it do a lot of things like, okay, it can detect HTTP traffic and automatically encrypt that for you. For our older workloads, our application level was doing like MTLS, and we had, certificates being configured all over left and right. With our switching to Cilium, we kind of just leave that at the network layer, and it makes like the workload debugging in dev easier because everything is unencrypted and you don't worry about it. It's all running on your machine. You can just see it all flying everywhere. When it gets to production, obviously security becomes more of a concern, and there having the network layer just handle that for you has been incredible. The next bit is really kind of how do we handle cross cloud networking. Cilium kind of, like I said, handles most of it in a single cluster. The cross cloud bit has probably been our biggest challenge because those links aren't super reliable. We just yesterday had a problem where Google Cloud had basically problems in and out of the internet, and we were having problems with some of our cross cloud workloads that basically everything appeared unreachable from our GCP cluster to our AWS cluster, and vice versa. So those problems are real. They happen. Luckily, they don't happen every day. And our solution at this point has more or less been to just try and architect the application to fail gracefully, though we're considering some solutions around dedicated peering between the two cloud providers and having like basically dedicated purchased fiber on a private network for us. And that will hopefully increase our reliability a little bit, but that can still fail too, right? And so like, if you're gonna do that, like, are you gonna buy 2 links there in case one fails and then you go with 2 providers? I think it's the same thing that you end up asking a question around, do I run on multiple cloud providers, right? When do you decide to do that, and how do you even do it? And that's really, really tricky and long discussion that we could have there. But at the end of the day, I think for us, our goal is to handle a full cloud outage and still be able to run our live streaming and video platform without our customers noticing. They'll be like, "Oh, Google's down. I thought you guys run on Google." Yeah, well, but we also run on Amazon, so it's still running. That's the dream. That's the dream. But I think the reality here that we need to recognize is sometimes when you're heading for that dream, you still have unsuspecting cross-cloud dependencies that pop up on you, and you're like, I didn't realize that there was a mandatory call across clouds that like the application is now failing on because we didn't test it. And we don't test it because it's like we hope not to have it happen. So
yeah. Well, there's only so much you can test too. I mean that's a whole other webinar for another day.
Exactly.
Yeah, in terms of, so I was going to ask you this question, 2-part, both hopefully fast.
Sure.
So the first question was really like, what is your use case for multi-cloud, right? And it sounds like because you want like to not have to worry about it one cloud, it's completely unreachable. Yep. That's probably your primary one, right? I mean, I imagine there might be some customers that don't want to use one cloud or another. I mean, that comes up sometimes, but
yeah. It does, but like we're not thinking about that as much as kind of the reliability side and the cost side, right? So both for us and for our customers.
That leads into my second question is, you mentioned tagging and understanding your cost really well. I mean, are you able to like fairly quickly say this is costing too much on this cloud, let's move that over to the other cloud? Is that something you do? Is it something that actually, because there's always this fear that like if I get locked into one cloud, then the other one's gonna be way cheaper. I need to move all my load over there. Like, but I mean, I don't think that's a real problem yet. But I was just
right.
You see it.
Yeah, you can play that game for so long. For us, it becomes more of a reliability play than a cost play. We have a number of customers that run in AWS, and in order to reduce their costs, like they'll upload videos into their buckets in AWS. We'll ingest those, and in order to reduce their costs, we're considering like running all of our workloads for ingests of assets that we detect are in AWS S3 in East 1 in our co-located processing region there. Then our customer doesn't have to pay the egress cost, right? Because their workload is right next to ours. The same thing comes for networking, actually. When customers are live streaming to us from their cloud infrastructure, we have like cloud transcoders and cloud compositors that are doing all these fancy things. We want as minimal hops as possible between the thing actually publishing the live stream and us receiving it for transcoding and processing. And one of the ways to achieve that is to co-locate again and make sure that wherever those customers are pushing from, we're running our servers right there with them. And so it's more about the reliability and performance play than it is about trying to do kind of a cost optimization for us. So yeah, does that make sense, Mike?
It does. It's fascinating, actually, like how deep you are into it. Like, with this problem, it's such a high scale problem. Those are always the most interesting to me because, any of us can take a function and load it into in Lambda and like run it, right? But to solve some of these real world, big problems, it's really exciting to hear how you're doing that. Let me see if there's a couple other questions. We only have 4 minutes, so I don't want to
Sure.
open up a 5-minute question, like that doesn't make a lot of sense.
I'll try and keep the answers quick. Try not to blabber on.
we talked about that. We talked about that. Yeah, so I'm going to throw out something that I know is a pain point for you because we talked about it, like Rancher.
Uh-oh.
At one
Oh,
point,
no.
there was a dream that you could help your cross cloud deployments. You know, maybe there's some kind of DevOpsy kind of experience there. I heard you use or tried to use Rancher at some point. Tell us about that and what you're doing
Yeah,
on the DevOps side.
yeah, I'll say one thing about Rancher is they've successfully pivoted. Early on, Rancher really was one of the first companies making easy orchestration tools with nice UIs. And when you're running kind of at a smaller scale, we were invested early on and like build things in Docker, run them. Rancher basically was that step up from Docker Compose that we really liked. Then software-defined networking with a lot of traffic became really hard. And we'd see the networking stack get stuck pretty frequently. And, you know, I don't think that there were a lot of people pushing as much network traffic through some of the bits and pieces that we were running as a lot of other people. And so we hit bottlenecks probably first. It was working pretty successfully until we really started to scale. And with Kubernetes, I think this is one of the things that's been so cool is the container networking interface is so extensible that people keep creating and improving the networking stack by spinning up whole new projects, but you don't have to change or do much at your application layer in order to try them out or see how they perform. So that's been pretty neat. I think I answered some of your question there, but the last bit on Rancher is we're using them locally for our whole dev environment. K3S has been awesome.
Yeah.
And they've changed from having basically their own custom stack, trying to compete in the orchestration wars, to fully being all in on Kubernetes. And yeah, I think that's partially why we're using them still.
Yeah, awesome. So there is kind of a question which has come up, which is like, why would you choose serverless over Kubernetes? What I'll say, and to summarize this conversation from my perspective, is if you're really pushing the envelope, you need to get down as low as possible into the infrastructure, and that's how you're going to be successful. And Kubernetes allows you to do that, right? Like you actually don't want the benefits of serverless. You want to get down into what's going on and be able to manipulate it. So that's what we're talking about here, right? This extreme example of like you can't really do this in serverless because you just can't get into the guts deep enough. So that's what we talked about today mostly. I mean, we ended up a little bit on how do we do it, right? Like how does this actually work in serverless? And like I said, it's totally fascinating to me. So hopefully some of you also thought it was fascinating. Now, the other side of it is if you want to experiment and you want to get something out quickly, like, hey, there's this business problem we need to solve and, we just need to cobble together something, just try it. Then something like serverless is way better. Your cost structure is going to be better. You don't have to put any infrastructure down. You don't have to worry about DevOps as much. I mean, you do. I mean, all of that still exists at some level, right? You can simplify it to do this quick experiment. And then, later you can decide, well, maybe I need to do Kubernetes or do some, more structured DevOps in the serverless world, which is getting stronger and stronger, going back to the ecosystem thing. It's like that's accelerating because of the popularity. So that's what I would say. Like if you're pushing the envelope, you're probably not going to get, huge value out of serverless, especially if you're running workloads continuously. The on-demand pricing just doesn't have the same interest, right? And then one of the things you pointed out, and I'll, from my perspective, is lambdas and the equivalents all have this warm-up problem. Right? So if you are doing spotty loads, but the loads need to respond quickly, still that benefit of per use pricing may not be great for you, right? And you need a quick response time all the time. Serverless is probably not the right answer for you.
But it's a great solution to get going quickly. It's a great solution to get going quickly. I mean, if I was starting a new company and was greenfield, and I kind of knew that, most of my application was kind of like CRUD operations and, a standard, what in the old days we used to just call the Rails app, right? It's like most of those use cases are served great by serverless. And so I think there's definitely a place for it. And the neat thing is that ecosystem continues to grow. I think it'll be really easy to move a lot of those things onto Kubernetes when you start to have some of these performance things that you were just talking about, Mike.
Yeah, I agree. So thanks everyone for joining, and Matt, especially thanks to you. Thanks for taking time out of your important skiing time to talk to us about this topic. And like I say, it was very fascinating, and I look forward to future conversations with Matt.
Yeah, great chat with you, Mike.
I appreciate your attendance, and this will be available for download tomorrow if you want to review it. Thanks, everyone. Have a good one.